Okay, we're here with our talk about dividing fractions. You ready to go?
Yes.
Okay, so there's a rule for dividing fractions, and you'll want to memorize that rule or a process over here. But before we do that, instead of just memorizing, you should always know why a rule works, okay? So let's figure out what the rule is together, okay?
Okay.
We're going to invent dividing fractions together. Sound good?
Okay.
All right, so first let's ask ourselves, what is division? So I'm going to give you a definition here, see if it makes sense to you. One definition of division is, division asks, how many times can one number fit into another number? So for instance, when we say 20 divided by 5 equals 4, that means that 5 fits into 20 4 times. Does that make sense?
Yeah.
Okay, good. So now let's do this with some fractions, okay? So how many times does 1/2 divide into or fit into 1? How many 1/2s are there in 1?
2.
Okay, so let's write that in math. 1 divided by 1/2 equals 2. Does that make sense to you?
Yeah.
Okay, now let's ask the same question about 1/3. How many times does 1/3 divide into 1?
3.
3. So 1 divided by 1/3 equals 3. We can keep going. Let's just jump up to how many times does 1/7 divide into 1?
7 times.
7 times. Okay, so do you see a pattern here? What? There's something going on here. Let's go ahead and write it. I've written here, there's something going on with the reciprocal. So now let's figure out what the reciprocal it is. The fraction is flipped over. So 1/2, the reciprocal of 1/2 is 2/1, or just 2. That's our answer here. The reciprocal of 1/3, what's that?
3.
3. The reciprocal of 1/7 is?
7.
So in some ways you could say, wow, when you divide, there's something happening with the reciprocal, right?
Mm-hmm.
Okay. Now let's do a couple more examples to see if we can flesh this rule out a little bit. How many times does 1/2 divide into 2?
4 times.
Okay, good. So let's write that with math. So 2 divided by 1/2 equals 4. Is that right?
Yeah.
Okay, now let's ask ourselves, how many times does 1/3 divide into 2?
6 times.
6 times, right? So 2 divided by 1/3 equals 6. Now it seems like we're getting something that's a little bit different with the pattern. We have the reciprocal, 1/2 would turn into 2, and then we're kind of multiplying by that first number. So it's 2 times 2 equals 4. And 2 times the reciprocal here, what would the reciprocal of 1/3 be?
3/1, so just 3.
Yeah, so then 2 times 3 equals 6. So now we're seeing a pattern about the reciprocal and multiplication, right?
Yeah.
Okay, so let's look at another example down here. This one's a little bit complicated, so I've drawn a picture so we can visualize it better. How many times does 1/4 divide into 1/2? So let's pretend that this half wasn't here. How many 1/4s are there in 1/2?
2.
2. Okay, now let's write this in math and see if that rule that we came up with of the reciprocal and multiplication works. So we'll say 1/2 divided by 1/4 equals 2. We know that's right?
Yeah.
Okay, so let's take the reciprocal of that 1/4 and rewrite it and make it multiplication. So 1/2 times 4/1, and that equals, you multiply the 1 times the 4 to get 4. In the denominator, the 2 times the 1 to get 2. So that's 4/2. And what's 4 divided by 2?
2.
2. So that seems like this rule that we came up with works. You take the reciprocal of the number that you're dividing by, and then multiply it by the first number, and that's how you do division with fractions. Make sense?
Yeah.
Okay, so let's go ahead and test that with a little bit more of a complicated example over here. I'm first going to restate our rule. Dividing by a fraction is the same as multiplying by its reciprocal. That's kind of the rule we said, right?
Yeah.
Okay, so let's do another example then. I've got a number here, and let's pretend that a circle is 1. So how many full circles do we have here?
2.
2. And then what else do we have?
1/4.
1/4. So we could write this as 2 1/4, right?
Yeah.
Okay, and let's make that into, let's go ahead and create that as without the mixed number. Can you do that for me? How would you create what's sometimes called an improper fraction out of that?
multiply the denominator by the whole number, and then add the numerator, and then just keep the denominator. So
Very good.
9 over 4.
Good. Very good. So same as 9 over 4. That was good mental math. Okay, so what we're seeing here is a picture that's 9/4, right?
Yeah.
Okay, now I'm going to ask you a question. What would that thing, 2 1/4 or 9/4, divided by 1/2 be? So we're saying, how many times does 1/2 go into this these colored spots here? So let's figure it out by just looking at the picture, okay? Okay, so here's 1/2. Here's another 1/2. So how many is that so far?
2.
Here's a third one. Here's a fourth one. And then how much of a 1/2 is this?
1/2.
It's a half of a half, right?
Yeah.
So we would expect the answer to be 4.5, right? 1, 2, 3, 4.5 halves,
Yeah.
right? And when we do what you made this into an improper fraction, 4 times 2 is 8 plus 1. So we would expect the answer to be 9 halves, right?
Yeah.
Okay. So now let's go ahead and do our process here and see if that's what the answer is that we get. Okay? To test our rule. Okay, so we're going to say this 2 1/4, that's the same as 9/4 we set up here. So 9/4 divided by 1/2. So here we have a dividing by a fraction here, and we said that's the same as multiplying by the reciprocal. So here we had 1/2. We took the reciprocal to make 2 over 1, and we turned it into a multiplication. Following so far?
Yeah.
Okay, so then to multiply these, 9 times 2 is what?
18.
And 4 times 1 is what?
4.
So we can rewrite that as 18/4, right? And then if you simplify it, what do you get?
9 halves.
9 halves. And look at that. That's what we were expecting. So that's what we looked at when we were figuring out this picture. We expected 9 halves. We followed our rule, and we get 9 halves, the same answer. So we can be pretty confident that this rule is right. And now you don't have to go and prove it to yourself every time. You can just memorize this rule, and anytime you're dividing by a fraction, just change it to a multiplication problem where you're multiplying by its reciprocal. Make sense?
Yeah.
Excellent. Good job.